Yesterday lecture we have to see the application of vector geometry. Two property we have seen. Next property or application, a quadrilateral is a parallelogram quadrilateral is a parallelogram if and only if its diagonals bisect each other. Its diagonals bisect each other. Proof. In this application or property, there are if and only if. Therefore, we have to solve conversely this theorem. We have to solve first the quadrilateral ABCD is a parallelogram. For this property, we have to take diagram. A, B, C, D parallelogram. These are diagonals. Point E, vector AB, DC. First we have to give suppose the quadrilateral ABCD, the quadrilateral ABCD is a parallelogram. आपण सुरुवातीला काय घेतलं हा जो क्वाड्रिलॅटरल आहे तो पॅरलोग्राम घेतलेला आहे. लेट A, B, C, D are the position vectors of the points A, B, C and D. We know this respectively. Therefore, vector AB is equal to vector DC. Vector AB is equal to vector DC. By the definition of position vector, vector B minus vector A is equal to vector C minus vector D. Right? By definition of position vector, we have to change the sides of B and D. A and D, that is vector B plus vector D is equal to vector C plus vector A. Divide both the sides by 2. Vector B plus vector D divided by 2. Vector C plus vector A divided by 2. This equation shows, that is the which formula we have to solve. Formulas: section formula for internal division, section formula for external division, number 3 midpoint formula, and number 4 centroid formula. This formula we have to show. For these formulas we have to show this formula: vector B plus D by 2, vector C plus A by 2 is midpoint formula. Therefore we have to show B plus D by 2 and C plus A by 2. Therefore we have to write let E point, this E point, be the point whose position vector, be the point whose position vector is E. या पॉइंटचा पोझिशन वेक्टर कुठला आहे? E आहे. फ्रॉम द अबव इक्वेशन, फ्रॉम दिस इक्वेशन, फ्रॉम अबव इक्वेशन, या इक्वेशन काय दिसतंय आपल्याला? इट फॉलोज दॅट द पॉइंट E, it follows that point E काय पहा is the midpoint of both the diagonals. Point E is the midpoint of both the diagonals from this equation. E is the midpoint of both diagonals AC and BD. AC and BD. For this formula, this point E is the midpoint of diagonals AC and BD. We have to show this, right? आपण प्रो काय केलंय पहा ई हा मिड पॉइंट हा AC आणि BD चा डायगोनलचा मिड पॉइंट आहे. कॉन्व्हर्सली काय प्रूव्ह करायचं कॉन्व्हर्सली we have to prove the diagonals of the quadrilateral. Suppose the diagonals of the quadrilateral ABCD, bisect each other at point E. Bisect each other at point E. तो आपण काय गृहीत काय झालं पहा suppose the diagonals of the quadrilateral ABCD bisect each other at point E च्या ऐवजी F घेऊ पहा थोडं सोपं जाईल आपल्याला F whose position vector is position vector काय पहा F whose position vector is F. The point F is midpoint of diagonals AC and BD. The point F, we have to show point F is midpoint of diagonals. Which diagonals? AC and BD. Therefore, आता AC and BD चा हा diagonal that is midpoint आहे म्हणजेच F is equal to by the midpoint formula हा AC चा हा F हा midpoint आहे म्हणजेच by the midpoint formula factor F is equal to A plus C by 2 and factor F is equal to जसा AC चाच midpoint आहे हा F तसा BD चा पण आहे that is by the midpoint formula factor B plus factor D by 2, right? That is A plus C by 2 is equal to B plus D by 2. Then 2 will be cancelled. A plus C is equal to B plus D. We have to 2 both the side cancel. Then we have to interchange D and A. It is C minus factor D is equal to B minus factor A, that is DC is equal to AB. Factor DC is equal to AB. आपण काय केलं पाहिजे या ठिकाणी F हा मिड पॉइंट घेतलाय डायगोनलचा मग तो पहिली सपोज पहा पहिली स्टेप आपण काय केलंय वेक्टर AB equal to vector DC घेतले आणि प्रूफ काय केलंय पहा E is the midpoint of diagonals AC and BD. आणि कॉन्व्हर्सली दुसऱ्या पार्ट मध्ये काय केलं पहा आपण दुसरा पार्ट E हा मिड पॉइंट घेतलाय कशाचा डायगोनल AC आणि BD चा आणि प्रूफ काय केलंय पहा वेक्टर AB is equal to vector DC. For these two cases, this implies The line segment DC and AB are parallel to each other. For these two cases, this factor AB and factor DC are parallel to each other. The length of DC and AB are the same. Length of DC and AB are the same. Therefore, the quadrilateral ABCD is a parallelogram. Therefore, quadrilateral ABCD is a parallelogram. That is we have to show is parallelogram. अगर quadrilateral आहे ABCD तो parallelogram दाखवा. त्यासाठी आपण दोन केसेस केलेत पहा. We have to take first two diagonals. Then we have to show these diagonals are E is the midpoint of these diagonals. Then we have to get E is the midpoint of these two diagonals. And next step we have to give one F is the midpoint of these two diagonals and take vector AB is equal to vector DC. Therefore, this quadrilateral ABCD is a parallelogram. We have to show. Next property we have to write. Property. The angle subtended. The angle subtended on a semicircle is right angle. On a semicircle is a right angle. The angle subtended on a semicircle is a right angle. Circle काढावं लागेल आपल्याला. Proof. Circle काढला. Semicircle घ्यायचं आहे. This is the center. These are diagonals, endpoints of the diagonals AB. Join this. We have to take any point on the circle C. Join this and this factor. Now we have to take origin is the center of the circle. Origin is the center of the circle. This is the radius R. This will be radius R. This will be radius R. Right? These two are factors CA and CB. या ठिकाणी पहा OA factor radius R आहे. OB factor radius R आहे and OC is radius R. Then we have to take circle. Origin is the center of the circle and any point C on the circle. Then we have to join AC and BC. And radius of the circle is R. Let A, B be the end points of the diameter. A and B is the end points of the diameter AB of the circle. C be any point on the circle. Let factor A, factor B, factor C are the midpoints of are the position factors of the points A, B and C are the position factors of the points A, B, C respectively. We know this. A, B, C are the position factors of the point A, B, C. Then this distance is vector C, right? Magnitude of vector C is equal to radius R. Magnitude of vector C is equal to radius R. Then it is clear that magnitude of vector A is equal to magnitude of vector B is equal to R. But in vector, we have to show this distance and this distance is equal distance. But vector OA in this direction and vector OB in this direction, these two vectors are opposite to each other. Therefore, vector B is equal to minus vector A. डायरेक्शन विरुद्ध आहे पहा दोन्हीची, डिस्टन्स सारखंच आहे, त्यामुळे वेक्टर बी इज इक्वल टू मायनस वेक्टर ए. कन्सिडर, काय कन्सिडर करायचं पहा, कन्सिडर वेक्टर सी ए डॉट वेक्टर सी बी. वेक्टर सी ए डॉट वेक्टर सी बी. सी ए डॉट वेक्टर सी बी इज इक्वल टू, we have to consider vector CA dot vector CB. By the definition of position vectors, vector A minus vector C dot vector B minus vector C, right? But we know vector B is equal to minus vector A. We have to write vector A minus vector C dot minus vector A dot minus vector C, right? That is, we have to write vector A minus vector C into minus 1 vector A plus vector C, right? That is, we have to write minus 1 as it is. Magnitude of vector A, magnitude of vector A square minus magnitude of vector C square. Take, multiply this minus 1, there we have to get magnitude of vector C square minus magnitude of vector A square. That is, we have to take magnitude of vector C, and magnitude of vector A is, magnitude of vector C is R, magnitude of vector A is R. That is R square minus R square, that is 0. आपण काय घेतलंय पहा, डॉट प्रोडक्ट घेतलाय दोन वेक्टरचा सी ए आणि हा सी ए, आणि आपल्याला हा राईट अँगल दाखवायचा आहे. अँगल सबटेंडेड ऑन ए सेमी सर्कल, हा सेमी सर्कल आहे, एवढाच सेमी सर्कल आहे. त्याला अँगल जो सबस्टेंड झालेला आहे हा अँगल सी, आपल्याला काय दाखवायचा आहे, राईट अँगल दाखवायचा आहे. दॅट इज 90 डिग्री दाखवायचा. त्यामुळे आपण काय केलं, सी ए आणि सी बीचा डॉट प्रॉडक्ट घेतला, पोझिशन वेक्टर डेफिनेशन वापरली. त्यानंतर आपल्याला माहिती आहे मॅग्निट्यूड ऑफ वेक्टर सी, दॅट इज द रेडियस ऑफ द सर्कल आर. दिस वे मॅग्निट्यूड ऑफ द सर्कल, दॅट इज द आर, दॅट इज आर स्क्वेअर मायनस आर स्क्वेअर इज 0. देयरफॉर सी ए डॉट CB, CA dot CB is equal to 0. This dot product is 0. This implies that CA and CB are perpendicular to each other. Therefore, हा dot product 0 आलेला आहे. याचा अर्थ काय, वेक्टर CA and वेक्टर CB are perpendicular to each other. Vector CA and vector CB are perpendicular to each other. That is, a perpendicular आहेत दोन लाईन CA आणि CB. याचा अर्थ काय रे, मेजरमेंट ऑफ अँगल ACB, ACB or BCA, ACB is equal to 90 degree. Hence, the angle, त्याच्यावर काय म्हणते पहा आपल्याला, therefore the angle subtended on a semicircle is right angle. Is a right angle. In this lecture we have to show two properties. First property is which property? The quadrilateral is a parallelogram. And second property, the angle subtended on a semicircle is a right angle triangle. Next chapter we have to show next property and examples of these properties. Topic.